If you read the headlines lately, you think the American Southwest is on the verge of collapse. Predictions regularly claim that the taps could run dry as soon as this summer, leaving major cities like Phoenix completely uninhabitable by the end of the century. And looking at the environment, those fears seem justified. This is one of the most hostile places on Earth, where extreme temperatures routinely exceed 110 degrees Fahrenheit and sudden, bizarre flash floods tear through the landscape. All of this happens despite the state getting barely 13 inches of rain in an entire year. Yet, despite this unforgiving climate, over 8 million people live here. Every single day, they manage to flush 41 million toilets, take 10 million showers, and consume a staggering 6 to 7 billion gallons of water. To understand why the state hasn't already collapsed, we have to look at the century of engineering and policy that has defined its existence. The panic usually stems from visuals like this. The state's primary lifeline, the Colorado River, is currently in a structural deficit, meaning more water is taken out than nature puts back in. You can see the scale of that deficit in the stark white bathtub ring mineral deposits on these rocky cliffs, showing exactly how far Lake Mead has dropped. While a dropping water level looks like a death sentence, it is actually the latest hurdle in a 100-year effort to stabilize life in the desert. Living in this desert without heavy engineering was never an option. When European settlers arrived in the 1860s, they found themselves geographically trapped around the few areas with fresh water. To begin farming, they had to revitalize a 500-mile canal system that ancient Native American inhabitants had relied upon for centuries. But those early settlers faced a recurring threat. The sun-baked desert soil is highly non-porous, meaning seasonal rains create rapid runoff that turns dry washes into violent, destructive flash floods. These sudden floods routinely wiped out early dams and reservoirs. In 1890, the Walnut Grove Dam gave way after heavy rains, sending a 50-foot-tall wall of water down the canyon, killing 50 people and washing away entire company headquarters. News of the disaster prompted a lobby for federal aid. The U.S. government responded by building massive infrastructure, like the Roosevelt Dam. By anchoring these structures between steep, rocky canyon walls, they established permanent control over the chaotic Salt River. By physically insulating the Salt River from major floods, engineers provided the state with its first stabilized water supply. With a stable supply, the region surged after World War II. Thousands of veterans returned to build lives in the valley, and by 1949, tech manufacturing firms like Motorola began establishing a foothold, turning mining outposts into tech hubs for aerospace and defense. This mass migration accelerated in the 1950s as affordable air conditioning became widely available. For the first time, families and retirees could comfortably tolerate the extreme summer heat year-round. But as the suburbs rose, the water supply fell. By the mid-20th century, residents were pumping groundwater 500 times faster than rainfall could replace it. Aquifers began to collapse, and in some areas, the land itself started to sink. Officials knew they needed a new lifeline. After years of conflict with California, political leaders secured the Colorado River Basin Project Act in 1968, authorizing the Central Arizona Project, or CAP. The CAP consists of a 336-mile-long aqueduct that carves through the barren terrain to reach key population centers like Phoenix and Tucson. Moving that much water requires immense energy. Because the liquid travels 2,900 feet uphill along the way, the system uses 14 massive pumping plants, making the aqueduct the state's largest single consumer of electricity. This man-made river allowed major cities to thrive, but the political strings attached to its funding created a new set of challenges for the future. To get the aqueduct funded, the federal government issued an ultimatum. Arizona had to accept junior water rights, meaning they would be the first to face cuts if the Colorado River ran low. Furthermore, they had to pass strict laws to stop the overpumping of groundwater. This led to the 1980 Groundwater Management Act. The law outlawed decorative lakes and mandated that no new neighborhood could be built without proof of a guaranteed 100-year water supply. Cities also pushed for a cultural shift. Instead of trying to make the desert look like the East Coast, municipalities like Tucson and Scottsdale literally paid homeowners to rip out their lush green lawns in favor of drought-resistant desert landscaping. Even leisure industries had to adapt. By 2006, Arizona's golf courses had reached a milestone, drawing approximately 28% of their irrigation statewide from treated wastewater rather than pristine groundwater. By legislating a respect for the desert environment, the state actively insulated its urban centers from the exact crisis the media is currently predicting. Which brings us to the present day. The ongoing megadrought has finally triggered a Tier 1 shortage, activating Arizona's junior water rights. This chart shows the scale of the resulting cuts. Arizona lost 512,000 acre-feet of its supply, a 30% reduction in the water carried by the aqueduct, and an 8% loss of all water used annually across the state. But despite that loss, the taps in major cities didn't go dry. Instead, the agricultural sector took the hit to ensure municipal drinking water remained protected. You can see the result in the fields. Agricultural canals have dried up, leaving behind fallow, unplanted dirt as farmers pay the price to keep the cities alive. The current stability of the municipal water supply is a direct result of the calculated, strategic sacrifice of the state's farming economy. Even if the river system collapsed entirely and the water stopped flowing through the canyon, it wouldn't mean an apocalyptic end for the state. While a total collapse would cause trillions in economic damage, urban centers have a fallback. The state has spent decades water baking, recharging underground reservoirs as an emergency reserve designed specifically for a moment of crisis. That time could be used to implement the next stage of engineering, such as piping in desalinated water from the coast of Mexico or California, using solar power. Using the sun to move water has deep roots in the region. As early as 1903, local inventors were building mirror-lined sun engines to boil water into steam, driving the mechanical pumps needed to irrigate the desert. As long as there is a willingness to engineer, legislate, and adapt, Arizona stands as a testament